So here we will get started. This is binary search tree. So this is the basic structure of the binary search tree. Here you will notice that it is a root node. There will be a root node and all the nodes will be directed to it. There will be no cycles in it. If you will see the data here in this root node, the left side of that this root, uh, it is called left subtree, and the right side will be called uh, right subtree. Here you will see the data behind this root data are all smaller than the ones it has. It can have equal data also, and in the right subtree all the ones are graded. Same goes for the 3, and the same goes for the 7. Here 1 and 4, 6 and 8. 6 is smaller than 7, 8 is bigger than 1. This left and right node, if this is left node and this is right node, then what node this will be? It is left and left node. This will be right and right node. So we are here first learn to define the structure. You, in this we are defining a new data type. Here if you will see on these syntax, struct telling the computer that we are going to define a new data type. Here the variable, just like other data types, have the variable as int, float, long, like this we can provide, and we have to write the all the materials in it in a curly braces giving a semicolon. Here is an example. Let's think that we are going to build our dream home, and in that home we will go only when we are required to get a phone number or the address of the home which are nearby, or any home which or any home's address. Now the node. So the idea of node is actually um, so in my 12th standard there was a topic of switch and hub. So all the computers which are connected to the switch, those all computers were called as nodes. Okay, and in this social media we are using mobiles to access the social media. So all the mobile users or the laptop users which are allowing us to see the data into it. Okay, so we all are acting as a different nodes. These computer, the laptops are acting as our nodes. Here the node concept is different. Here we will use this node variable to keep the address of the home. Here we have seen we will keep the address. We will later we will see. We will learn about the searching in this tree, insertion, deletion, and this is the code for the structure making. I've already told you. We have made struct home and we have kept data into it, just like here we have kept data 5, and we will keep the address of the node of 3 node having data 3 and node having data 7. Those left and right addresses we will keep here. And type def struct home star node. This means that star means that it is an address, and we have given this whole thing a name as node, so we don't have to write this again and again. Oh, this got misplaced. Include studio stdio dot h standard input output dot h header and the standard library dot header. This is for the node creation. We will code it now. So let's go to the coding part. Starting I am doing here include a standard input output. You know about the standard input output. We do all these scanf, printf, all the things come here. And about this header, standard library dot h, it is for the memory allocation, which we will do in the process of node creation. First we create our hut, just trying to gamify this. In this hut we will have data and the address of its adjacent hut. Okay, for data we have used pointer, left hut address and the right hut address. Okay, we are using we will use semicolon here, it is a proper syntax. Now giving an different name to it, or we call an alias name. I type def struct hut pointer, we are not going to write it again. Now we will create a node, or node is just a structure of hut. We will create it and have its address. Okay, node create with having integer x. Okay, what is the syntax of it? We will write node temp temporary variable memory alloc. M stands for memory alloc, for allocation. Size of struct art. What will be the size of the, so the size of two addresses plus size of integer. Okay, and if memory allocation is unsuccessful, then return it and create again. Okay, I think this is best. Here we will give assign the data and assign the left and right addresses as null. Now return it. So the creation of the node part has happened. Now let's say we have a tree, uh, which I've shown here, this one. So root node we are given, and now we have to find 7 or any integer. Let's say it is x. Okay. So node search. Okay, search we have to find it. Node, we have root node and integer x. We have to tell whether it is in the tree or not. So here if you will see what is happening, from here root we will go and search for the this subtree and this subtree. Same goes when we will come from here, we will come here 3 at 3, then this part and this part, left and right, all the and on all the nodes until we reach root is equal to null, until we reach one of the leaf nodes, okay. So let's talk about this. We have to find the integer 4. Hmm. So we will compare 5 is greater or smaller than 4. If it is smaller than it is goes on the left part. If it is bigger than it is goes on the right part. It is smaller, left part. Here we will come 3. 3 is smaller or bigger than 4. It is smaller. So here we will go in right part. This is how the search function will be work. So if root data is smaller than x, then we will assign root is smaller. Root is smaller, so we will go to right. Root right is equal to search root right x. Okay, else if root data is bigger than x, so root left part we will dive into roots left part. with integer x. Okay. Now the third condition will be of course the same, but it will be equal. So printf we found. Okay. And we will return the root. Now what will happen if we will return the if we haven't found and it reached the null node? Okay. Null node means it is already reached at the bottom line and it can't go further. So for that condition, we will write here if root is equal to null, or another way is if root not root, and not root null value is 0 0 0 0 6 times, and this not, it will provide some number to it. Printf not found, then return root. Okay, we have to return root only because we are searching. Now we will come with the insertion part. Insertion is also has also kind of searching part. Int x. Let's see that we were finding 4 in the previous. Let's say we were finding here 4. Let's say it is 3 point. Here is 4, right? So let's say 4 is not there. Any other number is here. So we were finding through search algorithm we were finding 4, but we didn't find it, but we can attach it. Okay, insertion part. So here we can attach it, and through searching it, like 4 is smaller than 1, here comes 3 is smaller than uh, 4, so it will come to the right part. So search part is here also. So we will take this, and here. So what we did, we are searching for the right place. Okay, and this is the condition of root is equal to x, root data is equal to x. So it has already exists, so we don't need to insert it. But uh, if we found the real place of it, okay, so if root here reaches null, then we have to return the that node. We have to return that node, because if 4 is not there, let's say 4 is not here, so 3 left part is null. So 3 so logically it will come to the left part. So to join left part of 3 is null, and root has become null. Okay, because from here root left, sorry, root right, uh, root right part will become null, because root is of 3, root right is already null, so we are not going to search it. Okay, here search, if we will do, oh sorry, insertion, if we are going to insert the root and it is already null, so at null part, at root right which is null, we will get a node, and the here it is root and it's right, it is having a component of right address, so it will keep the address of the node which is created now. Okay, so this is how the insertion will occur, and now we will do the deletion part, which has to be understood carefully. Here if root in deletion, in deletion part we of course we have to search for the node, So node searching algorithm is same in this deletion and insertion. Now we found find the node. We found the node here. Okay. So what we will do? Let's consider what can be the cases here. Let's say we found 4, right? 4 doesn't have any left node or right node. Let's say we were finding let's say 4 is not here and we were finding 1. So 3 has only left node, has no right node. We are assuming that 4 is no node is not here. So for that, if a single child is present or double child is present, so for both the conditions we will write the code, and it's very easy. If root left is null, okay, so what we have to do is, here a concept comes. Considering that left node is null means one is not here, one is uh, not here, only 4 is here. So we have to delete this 3, okay, but 3 is having 4 only, 1 is not here, so left part is null. So what we have to do is that we have to return the this node, its right child, to the root, okay. We are going to return it and deleting this free, okay. And when we will return this child node, okay, we will write the code of this. We have now free the root which was at 3, and now return the temp variable which we have created. Same goes for the right side. Okay, so for both the conditions we have root, and the third condition is that we don't have any root. Let's say we have both root or we don't have any root. So here the condition comes that let's say we are going to delete 7 having both left and right node, 6 and 8. Or you may call we are you may say that we are going to delete the 5 which is having left, right and the whole subtree inside it. So what we will do it, let's say root has stuck at 5, okay. Now we have to delete it. So we will replace this integer 5 with a number uh, within its subtree. So how we are going to find the number? This number can should be smaller than 7 but larger than 3, 1 and 4. So of course we will not take the number from the left subtree. We are going to take the number from the right subtree. In the right subtree, the number which is smaller than 7, of course it is 6. So within the right subtree we are going to the leftest node and its integer, and we are going to replace it with 5. When the 5 will become 6 and here it will come 5, then we will delete the connection from it. We will delete this node and 5 if the integer 5 will go out of the tree. This is how we will delete. We are not going to delete the whole node, but we are exchanging the values and then deleting that particular node which we have uh, um, that particular integer node uh, uh, which we have made it as a leaf node, okay. So where is this VS code? Okay, here. So we are going to find the minimum value of the right side, minimum value of root right side, okay. Let's say we got the minimum value. Now what we have to do, we have to 6 We have to swap the value 6 and 5. Okay, so temp data is equal to element, and root data is equal to temp data. Sorry, we are using here x, right? Now what we have to do is that we have found now the swap has successfully happened. Now we have to delete it. Oh, how we will delete it? We will delete it. The we will delete it. Just write root right is equal to delete. Sorry. Temp temp. No. Maybe. Oh, I also got confused here. So we will let's check. AI will do this. Maybe control plus I. This. Okay. So this was the function which we were earlier going to use to find the minimum value. Here you are saying that it is going to the left side with the root. Okay. Here copying the data and deleting the root right, deletion temp data. Okay, done. Here return root. Okay, temp data is of course the x which we have, which we want to delete it. Now let's consider that why we have written root right deletion root right data. Here the root is here, so we'll go into right. Of course the minimum value temp will be here. Okay, so here it came root right, root to right side, and we have given right side, right, in the deletion part also. So in the from the deletion part it will come here, it will search in the right side and delete the sixth, um, and this we have searched the value, so it is 5 and we have deleted it, and it will return the this 8 node address. Oh yes, why it is returning this address? Why it is not stucking at this 5? Actually, there is no fault. The structure of the data, this tree will change and it will become the root node. This is the case here, and we cannot return null. If we will return null, then the root value will be null and there will be no tree. Now, I consider that you have learned it. Actually, I tried my best to pour the knowledge which I gained by practice. And now it's time to say goodbye. Thank you for watching this video.